So inside the engines, this is what you're ending up creating. This is a zinc sleeve that ran in a bench test for 175 hours. You can see all of that pitting. This is the same thing that would be happening to this aluminum if we ran it for 175 hours. The difference is the zinc is more reactive. So what are we doing with this anode? Why does it work so well? Well, the rest of the anodes in the system are very far from the thermostat. So this piece, which is why Suzuki started making this replaceable, ends up giving itself up. But this is not just happening here. The water from these engines is flowing up through the impeller and it's getting thrown to the very top where the thermostat is. And so it's traveling by a lot of aluminum. The number of electrons that are flowing out of this aluminum is in the hundreds of trillions at just a negative 0.1 milliamp. So that means you're losing about 60 trillion atoms at a second, per second. That can only happen from a certain volume, a certain area. You wouldn't be able to lose that many atoms from one single spot, partly because the electrons are all negatively charged and they can only be so close to each other. Speaking of that, the reason why with DC current you see a positive or a negative, depending on if you switch these, you would see a positive current. As it's set up, we see a negative current. The reason is the electrons are negatively charged, they're flowing towards the positive terminal. So on a regular DC system like your car or the boat here, the electrons travel from negative to positive. Here, we're showing that the electrons are going the opposite way because they're traveling from the aluminum into the water. And so that's why we get a negative current. If you were to flip these, it would show positive.